Hi everyone, I'm just going to go through question 11 from today's work. So on the same diagram, sketch the graphs of y equals negative the modulus of 3x add 4 and y equals 2x minus 9. I'm going to begin with negative the modulus of 3x add 4. So I know it has a y-intercept of 4 and continues down like that. So this is my line of y equals 3x add 4. Modulus of that would mean that it can have no negative y values to that. So this will therefore be coming up here. So this is my graph of y equals the modulus of 3x add 4. And therefore, if I want negative the modulus of that, it's therefore going to be essentially multiplying all my y values by -1 or a reflection in the x-axis. So this is my graph of y equals negative the modulus of 3x add 4. Then I have the graph of y equals 2x minus 9. So I know that my y-intercept is going to be lower here, and it's going to look something like, just a sketch obviously, but if you imagine, for the sake of this graph, I'm just going to change this slightly. So that comes up there and down there, and this will be the graph of y equals 2x minus 9. Right, finally, that's taken me so many attempts to try and fit it on the same graph. Okay, so now I've got my two graphs as one. That's those two graphs done. Solve the inequality negative 3x add 4 is less than 2x minus 9. Well, what I'm going to do is think that, well, if you think about it, this part of the graph is equivalent to the graph of 3x add 4, isn't it? Remember our original graph? It just went up like that, 3x add 4. So to find my solution, if you think of this bit as the line of y equals 3x add 4, because if it continued, it would have been the graph of y equals 3x add 4. And then I want to see where that intersects with the line of y equals 2x add 9. So 3x add 4 is equal to 2x minus 9. Then if we go to solve this, so take away 2x, I'll get x equals -13. Okay, so that looks good. It looks like this point here is my value where x equals -13. Now, this is the graph of y equals 2x minus 9. If I think about it, this is actually the graph, if I think about this line alone, this is the line of y equals minus, I'll do it in a different colour. So that's one of our solutions. And this line here, which is intersecting with the line of y equals 2x minus 9, is in fact negative the line of y equals 3x add 4. And I want to see where that intersects with 2x minus 9. So that's going to go minus 3x minus 4 equals 2x minus 9. And if I add 3x on both sides, I'll get 5x here. And add 9 on both sides, I'll get equals 5. So my value here is x equals 1. Okay, so that looks good as well. So now I have my two values of x. Here x equals -13 and here x equals 1. Now it's very important the format of the inequality. This one says where the line of negative the modulus of 3x add 4, which is this red line, isn't it, is less than 2x minus 9, i.e. where for what values of x is the red line underneath the blue line. So here I know my value of x here is -13. Therefore one of my solutions will be x is less than negative 13. Or here I can see my values of x are increasing when it's underneath here. X is greater than 1. Now, that's the final answer to that question. I just want us to discuss what would happen, in fact, if this inequality sign was the other way round. If this inequality sign was the other way round, it would be saying, solve the inequality where the modulus of 3, negative the modulus of 3x add 4 is greater than 2x minus 9. Well, for that situation, I'd be looking at the bit where it is above the blue line. Yeah. Therefore, my inequality would be trapped between x is negative 13 and x is 1. Okay, I'm going to also put a video which explains it really nicely, but hopefully that helps somewhat. Please email me in the event that it doesn't. Thank you guys. Bye.